Today we're going to show you how to look at a projectile motion problem, figure out what it is asking for, find the right equation to use, and then solve it step by step. So we're going to do just 3 different problems together, and each one is going to teach us something different. So the X is always going to be the horizontal, while the Y is going to be the vertical. A way that you can remember this is horizontal is like horizon, like the sunset. So you can always remember horizontal, horizon is like that. And then so for Y, I always think of Y, the stem of the Y here is up and down. So that's a way to remember. So what we're going to do is the X, the velocity is going to stay constant. Another thing we need to remember is that gravity is always going to equal 9.8 meters per second. So that's just one we got to memorize. It's going to be in so many of our problems. Before we do this first problem, we just need to remember we're going to always be having 2 directions happening at the same time. So the ball, pretend I'm throwing a ball here, the ball's going to be moving horizontally, but the ball's also moving vertically as we throw it. So we have to treat it as 2 separate problems. So horizontal motion is going to be our X, and vertical motion is going to be our Y. So right now we have our horizontal acceleration is going to be 0. So we know what our X is going to be. So we will put down 0 for our X. Our vertical acceleration is going to be gravity that we put right here. So Y will equal gravity. And this is really going to be the foundation for everything that we are about to do. So let's do our first problem together. An arrow is shot horizontally from a height of 4.9 meters above the ground. The initial speed of the arrow is 45 meters per second. Neglecting friction, how long will it take the arrow to hit the ground? The first thing when we see this, what is the question actually asking? That's what we really want to find out. What is the question actually asking? So let's see, we see the words here, how long? What are we looking for? How long? That's going to be time. So how long is going to be time? So t equals something. And let's find out what information we have in this. We have our height is 4.9. So we have height. Our initial speed is 45 meters per second. So we have our speed or velocity. So we will put V equals 45 meters per second. And just like we said at the beginning, we're going to have gravity. Anyone remember what gravity is? 9.8 meters per second. So we have a lot of information so far here, don't we? Now, there's something here that's also important. The arrow is shot horizontally. So here's our arrow. It's just shot horizontally. We need to find out how long it takes to hit the ground. That means our initial vertical velocity is going to be 0. So now we need to figure out what equation are we going to use for this one. Remember, we're looking for the amount of time it takes the arrow to fall. So we're looking at this vertical motion, because we're looking for this right here, right? How long it takes to hit the ground. This is our equation. So let's look at each piece here. D is our vertical distance. V1 is initial velocity. So I always think of first place initial velocity, V1. T is time, and then A over here is acceleration. So with all our numbers we have over here that we found, let's fill these in with our equation and see what we get. Let's solve this. T2 equals 1, and then we need to do the square root. Our answer becomes 1 second. So notice something really important here. 45 meters per second. That didn't even matter for this question here. So sometimes when you're doing questions like this, they will give you extra information, especially on a test. It'll try to trick you, and you won't need that information to solve it. How we remember this is that we are finding how long it takes the arrow to fall. And falling is vertical motion, and it's falling down. And so this was the horizontal motion this way. The main thing is we just figure out what equation we need to use, and then we just solve it like normal and can get the answer. But where people mess up on these is they don't know what equation to use, and then that will throw off the whole question here. So let's do a recap here on what we need to do. So we have X and Y. We're doing X and Y because X, remember, X is our horizontal and Y is our vertical. So let's look at what information we have in each column. So we have our 45 meters per second is a horizontal information, and then that'd be constant. And then on our Y column, it's 0 meters per second initially. We also have our gravity. So if it's asking how long it takes something to fall, when something is falling, it's going down. So we are thinking vertical motion. So we'll use our vertical motion equation, and that would be this. Remember, on these two gravities, that's going to determine the falling time. So this would be a vertical motion problem, and then this would be our vertical motion equation. So let's look at another one and see if we can find the hints and figure out which equation we will need to use. A quarterback throws a pass at an angle of 35 degrees above the horizontal with an initial speed of 25 meters per second. The ball is caught 2.55 seconds later. Determine the distance the ball was thrown. All right, so before we solve it, let's find out what we are looking for. Determine the distance the ball was thrown. It tells us right here what we're looking for. We're looking for distance. Distance, or D. So D equals something is going to be our final answer. So let's draw our football here. Here's our quarterback. They're throwing the football. It's going in arc. Is this an art class? But there's our quarterback and there's the football going in arc. And we know that it's going to be 35 degrees. So this time we're looking for the horizontal distance because we're finding the distance the ball was thrown, horizontal distance the ball was thrown. So we know we need our horizontal distance equation. Do you know which one that is? Our horizontal distance equation. If you said horizontal velocity times time gives us horizontal distance, you are correct. However, we have a problem. We were given the initial speed, but we don't know the horizontal velocity yet. The 25 meters per second is the total velocity, but we need to break it down into horizontal and vertical pieces. Since we're interested in the horizontal motion, we're going to use cosine first. So let's fill this in. Okay, so for the velocity, we put in our 25 right here. We're going to do our cosine on our calculator. This 35 is our degrees. This circle with the dash in it is where our degrees go. So type that in your calculator and you should get this, 20.5 meters per second. So now we know the horizontal velocity. Yay! Now that we know the horizontal velocity, what equation do we need to use next? It would be this one. So let's substitute the numbers in. So we got that 20.5 from this when we just solved for here. And that 2.55 is from the question here. The ball is caught 2.55 seconds later. So let's solve this, and we will get 52.3 meters. And guess what? That is our answer. So the football traveled about 52 meters. Hooray! You did it. So let's take a look. How did we figure out? We just need to figure out what direction the problem is caring about, and then we use our formula. And most of the time, we don't need to have these formulas memorized for our classes. We'll have a cheat sheet. It's just needing to know which one and this one we needed to find the horizontal direction, so we needed to use the velocity for that direction. Let's try another one. All right, this one's going to be a little harder, so let's remember our process here. So let's read this question and figure out what we are finding. A cannonball at ground level is aimed 30 degrees above the horizontal and is fired with an initial speed of 125 meters per second. How far away from the cannon will the cannonball hit the ground? Okay, what are we finding? How far away from the cannon will the cannonball hit the ground? That's going to be distance. We're going to be looking for the distance. So the distance equals our answer. Now let's draw our little cannonball here. Okay, here's our cannon. We know it's at a 30-degree angle, and we know it's traveling 125 meters per second. This question's asking us, how far away does it land? So it should land right here. How far away is that from here? We're looking for horizontal, right? So how far away will it land? That's going to be horizontal. Okay, so when we're looking for horizontal distance, we need this equation here because we need to find the horizontal velocity and the time so that we can solve this. But we can find the horizontal velocity right away. Our horizontal velocity here is going to be Vx 125 cosine 30 degrees. Put that in your calculator and you will get 108.3 meters per second. All right, so we have this one done, but we don't know the time. So we need to figure out the time so we can use this equation here. So we're going to have to switch to vertical motion to find the time. Gravity is going to be controlling our vertical motion here. So let's first find the vertical velocity. All right, put this in your calculator and you should get 62.5 meters per second. Now we know how fast the cannonball initially moves upward. So we have our initial vertical velocity right here. And because the cannonball starts and ends at the same height, we can use the projectile flight time relationship. So that will be time equals 2Vy over gravity. Let's put our numbers in here, and then we will solve and should get 12.8 seconds. All right, we officially have everything we need now to solve this problem. Now that we have time, we can put our time in here, and now let's pop in the numbers and go to our initial equation that we were looking for and solve. So this 108.3, we have that from solving down here. And then our time, which is the 12.8, we just found that and solved for it over here. Multiply those two together and you will get 1,380 meters is how far it traveled. Yay, you did it! Remember, the biggest thing when we're looking at these questions is to find out what equation we need to use. Drawing out little pictures like this actually really helps you to see where it's going. Is this going to be a horizontal or a vertical question?